All right, we're going to get started here with 4.3. Welcome back to me talking to you instead of all those videos. I got my computer working again. So here we are, greatest common factor. That's what we're talking about in 4.3. This is a thing you're going to use a lot in math from moving forward. So we'll break apart greatest common factor. Greatest means biggest, largest, highest. So we're looking for the biggest number. Common is that they share. So we're looking at two numbers and this greatest common factor that they share. So factor is two numbers can be multiplied together to get another number. So 5 and 2 are factors of 10. To find greatest common factor, you do have to break it out like this division where you've got 10 and figure out what divides into 10. But we'll look more into that in just a minute. Greatest common factor of two or more numbers is the greatest number that is a factor of every number. Fancy definition to say the biggest number that the both of them have as factors. Divisibility rules, I gave this to you. This is exactly what the sheet is that I handed to you. You can look over this and it helps you to just know if something is divisible by looking at it and following these simple steps. 3 ways to find greatest common factor. This concept, rainbow, ladder method, Venn diagram method, are just ways that this PowerPoint shares it. I picked this PowerPoint off online, but this method is something we've already kind of looked at a little bit, but you want to find the one that works best for you to find greatest common factor and keep that consistent. This is the first method, which is making a list of them. So you start with the factors. We did this on the board where I put 1 and the number, and then we did 2. Does it divide into 2? Yes, you put that number next to the big number, and so on and so forth. Like for 12, you put 1 and 12, then 2, yeah, 6, 3, yeah, 4, 5, no, we're done. So those are figuring those out. You can also use the divisibility rules to figure out if 2 would work. It is an even number. Figure out 3 will work. 1 plus 2 is 3, so that's divisible by 3. This is a simple example of something that you could face later that you wouldn't just know. Like 12, I know you know, but something like 326, you have to see if that's divisible by 3. By the way, it's not. But those are examples that you could do. So find all the factors of 18. Same sort of thing here. You do 1 and 18. You use the divisibility rule for 2. Yeah, 9, then 3. Yeah, 6. 4 doesn't work. 5 doesn't work. You're done, right? Because 6 was already on the list. How do we know we're done? You can see if you divide by any of the other numbers, you get a decimal. Don't really feel like you need to go that far unless you're not understanding. And then you want to really try any number between those two. List of all factors, you can write it out like this. This is where you're kind of writing them down. This is how you actually give an answer. So if it says list all factors in a list, you would go 12 colon 1, 2, 3, 4, 6, 12, that sort of thing. Find the largest factor both numbers have in common. So now we're looking at 12 and 18. The biggest number they both have in common is 6. Yes, 18 has 9 and 18 and 12 has 12, but they don't share that. They don't have the common factor. So that's why 6 is the greatest common factor. Method 2 is the ladder method. This is prime factorization. So you can draw like this. By the way, getting used to this sort of a drawing will help you in Algebra 2 because you'll be doing something with dividing quadratics to where you do something like this. But that's not now. So this number ladder, you can see, let's say we're going to find the greatest common factor between 6 and 8. You can do this at one time instead of doing the 2 lists like we did with 12 and 18. And you can see, hey, these both have 2. You get 3 and 4. And then that shows us, we ask, oh, does 4 go into 6? No, it doesn't. 3 doesn't go into 8. And then 5 doesn't work. We're pretty much done. Because obviously 6 is going to be a factor, but not of 8. And that's the end of 6's factors. So we just look and see, hey, the greatest common factor that they both have is going to be just 2, because that on the left is their greatest common factor. Yeah, and if you had more factors you could take out of both of them, you would multiply them together and get the greatest common factor. The Venn diagram. So this is building off of our factor trees that we had done previously in the chapter. You can see this breaks down the 12 and the 18 the same way, and you get these prime factors. So for 12, it's 2, 2, and 3, and for 18, it's 2, 3, and 3. And what you do with this Venn diagram, which is two circles over each other, if you don't know what a Venn diagram is or you haven't seen them in a long time, they look like this. So these could be sideways, these can be up and down, whichever way. So we write the prime factors. So 12 had 2, 2, and 3, and 18 had 2, 3, and 3. So they both shared the two, one of the 2s and one of the 3s. They both had that. So we put that shared, and then the extra 3 was unique to 18, and the extra 2 was unique to 12. So that's how you write the Venn diagram. And then for the greatest common factor, you simply multiply the middle of the GCF, middle of the Venn. So 2 times 3. So the greatest common factor is 6. So try one of those methods on each one of these. And I'm actually not going to give you the answers right now. So if you're not confident on what the greatest common factor is, then let me know in class tomorrow.